I'm going to start today with a controversial statement. No one actually knows who will win the AI chip war. Not NVIDIA, not AMD, not Google, not Amazon, not Microsoft, not Apple, not Intel, and maybe not even TSMC.
Wait. Mr. Professor, that sounds crazy. Everybody says NVIDIA is basically printing money. Their GPUs run everything in AI.
Yes, that's the current narrative. NVIDIA shipped millions of Blackwell GPUs and built giant AI systems where dozens of GPUs behave like a single supercomputer. In a nutshell, GPUs became the engine of modern AI.
Exactly. So that means NVIDIA already won the race, right?
Slow down. History in technology rarely works that way. Let's take a step back.
All right, but you have to explain that.
Back in 2012, something happened that changed everything. A neural network called AlexNet crushed the competition in an image recognition contest.
Yeah, I've heard that was the big bang moment for deep learning.
Exactly. And the secret weapon wasn't a new chip. It was a gaming chip, the GPU.
Wait, gaming hardware started the AI revolution?
That's right. GPUs were originally designed to render graphics. When you render a scene, you compute millions of pixels at the same time. That requires parallel computation.
And neural networks also need parallel computation.
Exactly. Neural networks operate on huge matrices of numbers, thousands of small operations happening simultaneously. GPUs were perfect for that.
So GPUs became the workhorse for AI training.
Correct. GPUs run the two major phases of AI, training and inference.
Training is when the AI learns. Inference is when it actually answers questions.
Precisely. Training consumes massive compute power. Inference is when AI powers real-world apps.
Like ChatGPT or voice assistants or recommendation systems.
Yes, when you order coffee in an app, talk to your earbuds, or get product recommendations, that's inference happening.
Okay, so GPUs dominate training. That explains NVIDIA.
Yes, and their biggest competitor is AMD, whose Instinct GPU line is gaining ground.
But NVIDIA still leads because of CUDA, right?
Very good question. NVIDIA built a proprietary software ecosystem called CUDA. Developers rely on it heavily.
So switching to AMD is difficult.
Exactly. Software ecosystems can lock in entire industries.
Then again, why are companies building their own chips?
Now we arrive at the second category of AI chips, custom ASICs.
ASICs, application-specific integrated circuits?
Correct. Think of GPUs as Swiss Army knives. They can do many things.
And ASICs?
ASICs are specialized power tools designed for one task only.
So they're faster.
Often, yes, faster and far more energy efficient. But there's a trade-off.
You can't change them once they're manufactured.
Exactly. Once the silicon is etched, the design is fixed.
But if they're better, why doesn't everyone build them?
Because building a custom AI chip costs hundreds of millions of dollars.
Okay, so only the big tech companies can afford it.
Exactly. And those companies are the hyperscalers.
You mean Google, Amazon, Microsoft, Meta?
Yes, let's start with Google.
Google invented TPUs, right?
Correct. Tensor Processing Units. Their first TPU appeared in 2015.
And they helped invent the transformer architecture.
Yes, the architecture behind most modern AI models.
So Google might secretly be ahead?
Some engineers believe their TPUs are technically very competitive.
But they mostly keep them internal.
Exactly. What about Amazon? Amazon Web Services developed two major chips, Inferentia and Trainium.
Those run AI models in their data centers?
Yes, entire AI supercomputers built without NVIDIA GPUs.
That's bold.
Very bold.
And Microsoft?
Microsoft is working on its own Maya AI chips for Azure.
Okay, this is getting crowded.
Very crowded. And we haven't even mentioned Broadcom yet.
What do they do?
They help hyperscalers design custom chips. Think of them as the engineering partner behind the scenes.
Ah, the silent winner.
Perhaps.
So are there startups too?
Oh, yes. Companies like Cerebra Systems build giant wafer-scale processors.
Those chips are enormous.
Some of the largest chips ever built.
Okay, but what about AI in phones?
Ah, that's the third category. Edge AI chips.
Edge, meaning local devices.
Exactly. Phones, laptops, cars.
So those use NPUs.
Correct. Neural processing units integrated into system-on-chip processors.
Like in iPhones.
Yes, Apple includes a neural engine inside its M-series and A-series chips.
And Android phones?
They use chips from Qualcomm and Samsung Electronics.
So AI will move from the cloud to devices.
Exactly. Over time, more AI will run locally.
That improves privacy too.
Yes, and latency.
And what about those flexible chips, FPGAs?
Ah, yes. Field Programmable Gate Arrays.
Those can be reprogrammed after manufacturing.
Exactly. Very flexible, but not as fast as ASICs.
Who makes them?
Mostly AMD after acquiring Xilinx, and Intel after buying Altera.
Okay, this market sounds completely chaotic.
That's actually a good word.
But there's still one company making almost all of these chips.
Exactly.
TSMC.
Yes, TSMC manufactures the majority of the world's advanced AI chips.
So this also makes this a geopolitical issue.
Very much so.
That's why the US built new fabs in Arizona.
Correct. Semiconductor manufacturing is now a strategic priority.
So let me see if I understood everything.
Go ahead.
AI chips come in several categories: GPUs, custom ASICs, NPUs for edge devices, and FPGAs.
Exactly.
NVIDIA leads today with GPUs, but hyperscalers like Google, Amazon, and Microsoft are building their own chips.
Correct.
And Apple, Qualcomm, and Samsung are pushing AI directly onto devices.
Very good.
So the future AI champion isn't guaranteed.
Precisely.
Thank you, Mr. Professor. Now I understand that the AI chip race is far more complex than just NVIDIA dominating GPUs.
Yes, and here's the deeper lesson. In technology, the current leader rarely controls the entire future. New architectures appear, new software ecosystems emerge, and sometimes the next revolution comes from a company nobody is paying attention to yet.